Okay, so what I thought I'd do for today is kind of remind you through summary notes on formulas, facts, and relationships that you guys need to be practicing if you're aiming for a grade 4, grade 5 or better. Okay, so these are formulae that you need to know. They're not given to you in the exams, so you need to practice these either through the Leitner method. Now, if you're not sure of a memory technique, then I would recommend the Leitner cards. If you go to YouTube and just type in Leitner card memory, then you'll get some hits, which will give you an idea of how to use that technique. But you certainly need to remember these guys. So I'll show you the sheets. You can stop each one, and then I'll discuss a little bit about each one. Just remind you some key facts after I've shown you the individual cards. So one by one, and then you can stop and just have a look and see what you remember. Okay, so if you got to this stage, then I'll just talk you through some of the key ideas on each of the sheets, just to make sure you've got some way of thinking through what's important. Okay, so angle facts. They're bound to ask you some questions involving finding missing angles, so you must learn the correct language to use for getting full marks. If a question says explain, give reasons, or justify your answer, or show that, all those kind of words they use which imply you must give thorough reasons for every calculation and every number you put down on a picture. Okay, so we've got our basics about triangles, angles on a straight line around a point. Again, you've got to make sure you learn the language and make sure you're using the correct full words. Polygons, just remember that the exterior angle is really important. Is you're travelling along one edge, and if you were travelling and continued, then the angle made by turning to go down the other edge is called the exterior angle, and then the interior angle is the inside angle. And obviously the sum of them then will be on a straight line, so they must add to 180. Remember arrows, look for those on pictures, because the arrows are telling you that you've got parallel lines involved in the shape, and with parallel lines we then have the different rules for working out what's the same or what's missing. And look for the letters. So for example, if they told you this angle and they wanted this angle, then we can see that if we go over there, there and there, we create a backward Z, which means that these two angles must be the same, so therefore we can say alternate angles are equal, and so on. So again, make sure you know your angle facts, because they're bound to ask you at least one question involving finding missing angles. Okay, so also involving other facts that you need to remember. So for congruent shapes, we need to recognise there are different types of triangles, where if the triangles have these properties, then they will be congruent, which means they're identical. So for example, if we take this triangle here, the side angle side triangle, then if we have a triangle that's in this orientation, they said that was 10, that was 30 degrees, and this was 8, and then we had another triangle that was in this orientation, they said that this was 10, that was 30 degrees, and that was 8. Then we can see that we've got a side trapping an angle and another side, and we've got a side trapping an angle and another side, and they're identical. So these two triangles would be congruent because the side traps the angle, traps the side, is identical in both pictures. So practice a little bit about congruent shapes. Similar shapes we need to remember are enlargements of each other, which means that all the angles remain the same for both shapes, but the lengths have all multiplied up by the same scale factor. So we must remember to work out the scale factor by taking a new length. So for example, if this was 10 and this was 4, then we'd be saying the scale factor is 10 divided by 4, 2.5. And so therefore that means that if this was 8, then this would have to be 2.5 times bigger. So 8, 2.5, 16, 20. So that would have to be 20 centimetres if it was all in centimetres. So scale factors are involved in similar shapes, and they're an enlargement of each other. So if you want to prove if two shapes are similar, then you either prove all the ratios of all the corresponding sides are identical, or you can show that all the angles are the same and there is a scale factor between the sides as well. So lots of ways of doing that. Fractions, be really careful guys with fractions. When you're adding and subtracting, you need a common denominator, so we end up working through. And when you're timesing and dividing, it's not about common denominators, so please do not change them into common denominators. The only thing you've got to remember when you're doing timesing and dividing is it's always easier to have whatever numbers you're working with as fractions, whether they're improper or proper. So if they're mixed numbers, like the example here shows, then you would turn them into fractions first and then do the timesing and so forth. Just remember with division that we keep the first fraction the same, so we turn it into a mixed number into a fraction, but the second fraction we do the reciprocal of it, which means that we basically flip it over. A lot of people kind of remember keep, change, flip. So you keep the first, change the sign, and flip the second. So keep, change, flip seems to help some people remember how to do the division of fractions. Do practice those because I'm pretty sure there'll be a fractions question somewhere. But learn how to use your calculator because they do seem to be appearing on calculator papers a lot more than what they used to. So learn your fraction keys on your calculators just in case, as well as doing the traditional methods. Volume formulas, these two here that actually give you in the exams if you ever need to use them, so they won't insist that you learn these two formulas, but personally I always think it's better if you do, because you just know how to use them. But prisms, they certainly will expect you to know the formula for the prism. So all we've got to remember for prisms is that it's the area of the cross section, so the shape that goes through the whole prism, such that if you cut it anywhere you'll see the same shape. So if I cut it in the middle there, then I'm going to see the same parallelogram in this case all the way through. So it's the area of the cross section times the length of the shape, and the length is between the two faces which are identical at either end. A cylinder is a special prism, so again it will be about this idea of the area that goes through the shape. So in the case of a cylinder it's the circle. Got the same circle at the bottom there, or on the side, depends on how you have the cylinders. Don't forget cylinders can be in lots of different orientations, but it's still about the area of the circle going through the length of the shape. Got to remember that volume is 3 dimensions, so therefore all the units for volume will be in cubic units, so keep remembering that please. So that's volume formulas. All of these though guys you will need to remember how to use. These ones are given to you, but these ones you've got to remember them. Perimeter, again be careful, perimeter is all about adding lengths, never timesing, so perimeter is always adding lengths. So you've got to remember the perimeter is going around the edges of the shape and adding them together, and the units for perimeter are just single dimensions, so centimetres, metres and so forth. They don't give you any of these formulas guys, so you need to remember them. So the perimeter of a circle is C circumference is 2 pi r or pi d. You've got two different formulas for that, although they give you the same answer of course because two radiuses make a diameter. An arc length and sector area. So again we've got to remember that the arc length is just the outside bit, as if you was going around the outside of the circle that's produced, and O is the centre. So just remind myself, if you do the sector area on the area formulas. formulas coming up for that. Yeah, that's fine. Okay, so perimeters, just remember, is about adding lengths. Area, so again, none of these formulas are given to you, so you need to make sure you learn them and understand them. So the rectangle is the basic one, isn't it, guys, where it's base times the perpendicular height. And the triangle is the base times the perpendicular height and halved, because basically it's half a parallelogram. So again, we've got to be careful. Triangles can be in any orientation, but you just got to make sure that the two measurements are measured at right angles, perpendicular to each other. Parallelogram, it's like a shunted over rectangle. It's base times height, but again, you've got to be careful. The height is the perpendicular one between the two parallel sides. So be careful with the parallelogram. Circle, pi r squared, sounds like area to me. When I need the circumference, I'll just use pi d. So remember the circle song. If you haven't heard it before, go to YouTube, circle song, usually the first hit, and it'll be a way of trying to remember it. Area must always have square units. Okay, it's about covering up the space, and they're measured in squares, so square units. Sectors, just remember, it's part of a circle, so it's the fraction that you've turned. So theta is the angle. So just remember, theta is the angle of the sector, and we're dividing by 360 times the area of the whole circle. And there's an example here just to remind you how to use it. Surface area, just be careful with surface area. It is the faces, the areas of all the faces added together. So if you've got a triangular prism, then you'd have 2 triangles to work out, and you'd have 3 rectangles to work out. And then you'd work out the areas of those and add them together. Okay, they like surface area questions, painting, things that you do with surfaces, the amount of paint you use, the amount of wallpaper you'd use to cover up a room, all these kind of things that involve surface area because you're covering up something. So remember your formulas, guys, for area. Metric units of conversion and units to know. So if you haven't got these in your mind, guys, then you really need to be practicing these through either the Leitner technique or just basically getting a fresh piece of paper. If I'm not sure what I'm doing, then I'll just basically cover that up. I'll try and rewrite it from memory, and then I'll look at it again and see what's missing. I'd add onto my new sheet what I've missed out, and then the following day I'll be doing the same exercise. I'll be covering it up, trying to rewrite it to see what I remember, and then what I don't remember, add it on, and keep doing that for a few days, and then usually after 4 or 5 days you've started to get these into your long-term memory. So you need to remember these, particularly the volume and the area conversions. Watch for these. Just think of the units involved. So if you want square meters to square centimeters, then if you think of a square meter, it's a meter by a meter, and we turn them into centimeters, and then do the same multiplication for area. But do learn these, guys. They're not given to you in the exams. You need to remember them. And things to be particularly careful of is that you remember things like a litre is 1,000 cubic centimetres, and 1 milliliter is equal to a cc cubic centimetre, and so forth. And the centilitres, don't forget a litre is 100 centilitres, and so on. So all these units that you're expected to remember, guys, practice them. Shapes, really important that you remember all the different shapes up to 10-sided, the decagons, and you remember the special language associated with them. So dashes on lines means that the 2 lines are the same length. Could be 3 lines or 4 lines. So if you've got the same number of dashes, then they will have the same length. Notice when they've got different lengths, we have a single dash to show that these 2 are the same, and double dashes to show that these 2 are the same but different to the other ones. You need to remember all the properties of the quadrilaterals, guys. The things about line symmetries, remembering that line symmetries is where a shape will fold in half, so each half is identical. And order rotational symmetry, so the amount of turn, if you turn through 360 degrees, then it's how many times the shape looks the same. So for a rectangle, it would have an order rotational symmetry 2. Because it will turn twice, turn 180 degrees, it'll look like the same rectangle, turn through the full 360, and it goes back to the beginning. Every shape has order rotational symmetry 1 though, because you can always turn the shape round whole 360 degrees and it'll just look the same as it did at the beginning. But you've got to remember that some shapes have more than order rotational symmetry 1. Remember your polygons, names of them. So 5-side pentagon, 6-side hexagon, 7-side septagon or heptagon, 8-side octagon, 9-side nonagon, and 10-side decagon. Triangles, remember the special properties, really important that you remember things like equilateral, all lengths are identical, all angles are identical at 60 degrees, and so on. So practice these formulas, guys. Remember, for regular polygons, then you can find the exterior angle by doing 360 divided by the number of sides. So there's all these things that you need to practice and learn, guys. Other formulas, again, that they don't give you in the exams, so you need to remember how to work with these if you want your grade 5s and beyond. So we've got to recognise, for example, Pythagoras. C is always the longest side. That's important. No matter what orientation the right angle triangle's in, C is always going to be the longest side of the hypotenuse. The trigonometric ratios, theta's the key. Always think about where the angle is either going to be given or where you're finding it. Label that theta, and then every side gets labelled opposite theta, hypotenuse being the longest side and adjacent being next to the theta. And SOHCAHTOA is a way of remembering the trigonometric ratios. We've got formulas for equations of straight lines, so we need to remember the gradient is all about the horizontal movement and the vertical movement. The change in the y values, just be careful if you've got a gradient going in the opposite direction. Again, you put your 2 points on, create your right angle triangle. The distance there would still be the change in the x, but here we've got to remember it's a negative change. You've gone down to get back to the line, so that will be a negative gradient, so be careful with those. The compound measure formulas, again, make sure you remember these. You could use the triangles to help you decide which one can be found by covering up. So if I want the volume in the density formula, then I'd have to do the mass divided by the density and so forth. Proportionality, being introduced in a heavy way to the foundation tier this year. Wouldn't normally see it on the foundation tier, but it is basically about the relationships. So direct relationships, straight lines always going through 0. Really important that you remember it goes through 0. And the gradient of the line is always the thing that relates the variable on the horizontal with the variable on the vertical. So the y is equal to the gradient times the x here in this case. And this k is known as the proportionality constant, the thing that relates the two variables. If you do an inverse, then the key thing is that every coordinate on the inverse, so that will have a coordinate of xy, then x times y will always equal the constant. So it doesn't matter where you are on here, then the two values will always times together to give you the constant value if they're in inverse proportion. So inverse, remember, as one goes up, the others go down. Direct, as one goes up, the other goes up in the same proportion. So again, remember those formulas, guys. All right, number, facts and formulas. You've got to practice compound interest. So there's a formula to get that, and the percentage multiplier. So for example, if they said a 3% compound effect per year, per annum, then the multiplier would be 1.03 because we're talking about this is a decimal. So, and 3% extra plus the 100% original would be 103%, and then you divide that by 100 to get your multiplier. If that was an increase, so that was interest. If it's about a decrease problem, don't forget this formula works for decreasing as well. So they might say that you've got a 15% loss per year. Then that means you're left with 85%. So the multiplier would be 0.85. So again, this formula, although it is talking about compound interest in a sense, it should really say compound percentages. And what we're doing here is, if it's interest or you're increasing, then it's going to be 1 point something, and if it's decreasing, it'll be 0 point something. So be careful of those. Simple interest, you need to remember the difference between simple interest and compound interest. Simple interest is simply you get the same amount every year, whatever. So if they said it was 4% interest per year, then you'd work out 4% and then times that by the number of years, and that'll tell you how much interest you get in so many years' time. Fraction decimal percentages, do remember the conversions, and there are lots of ones that you need to know. On an uncalculated paper, you need to remember that an eighth is 12.5% or 0.125. If you're not sure of those, then just remember the basic ones and then keep halving down to get to eighths. Standard form, we've got to remember the front of a standard form number must be a number between or equal to 1 but less than 10, and the power of n must be a positive or negative integer, so a whole number. positive or negative there. And the power here tells you how many places the original part is going to go, or the front part is going to go up or down. Positive, it's going to move up, so power 5, 420,000. If it was negative 5, it'd be going the other way around. So, and just remember, standard form without a calculator, you'd be expected to know how to do these kind of questions. But do remember your calculator keys. On your calculators, you have a key that looks like that. If you've got Casios, that's your standard form key. If you've got Sharps, then it tends to look like EXP. But learn how to use your standard form keys on your calculator. There's always a question where it says write one number as percentage of another, guys, always, on every GCSE exam. So make sure you practice this technique. And just remember that the percentage change is always going to be the change in the amount divided by the original amount. I always like to think of it as fraction times 100. If the question says write the answer as a percentage, I'm looking for a fraction times 100. And the fraction will be about the change in something, so that could be an increase or a decrease. And it's going to be divided by the original amount. And then I'll tell you the percentage change. So I've given you an example here of how to think through that. There was an increase of £5 on the original cost of 30. What was the percentage increase? So the fraction was 5 over 30 times 100 give you 16.7% to one decimal place. Okay, so that's a run through of facts about numbers, algebra, all the things that you need to know, guys, all your formulas and facts.